I'm going to be using this Casio, 115. The first problem, you want to know if it's 1-to-1. This answer to this is yes. And the reason it's 1-to-1 is because not only is it a function where a function passes the vertical line test, a 1-to-1 function also passes the horizontal line test. An example of a function that's not 1-to-1 would be anything parabolic. Notice the parabola passes the vertical line test. It only strikes the curve in one spot. However, a parabola fails the horizontal line test. So it's a function, but it's not 1-to-1. So is a straight line a function? Yes, a straight line is a function. Is x cubed a function? Yes, x cubed, because it's odd, it would look like this. And that is, it actually looks like that. And that passes the vertical line test and the horizontal line test. Determine whether there are inverses. So the inverse of 1, 0 is 0, 1. That one checks. The inverse of -4, 5 is -5, -4. The inverse of -2, -2 is -2, -2. The inverse of -3, 6 is 6, -3. Yes, those two are inverses of one another. I am actually not going to use the definition of inverses. I'm just going to take the inverse of this first one and see if it equals the second one. So the first step you do is this is y equals -5x plus 12. I'm going to rewrite it as x equals -5y plus 12. I'm going to subtract 12 from both sides. That's going to give me x minus 12 equals -5y. I'm then going to divide everything by -5. So I'm going to divide this by -5, and I'm going to divide this by -5. That's going to give me y equals, or the inverse equals, -1/5 x. Oh, that looks good. Plus 12 over 5. That does not look good. No, that is not the inverse. 1-to-1. All right, let me see. 3, 3, 3. No x's repeat, so it is a function. 6, 1, 8. No y's repeat, so it is now a 1-to-1 function. So I'm going to find its inverse. That's going to be separated by a bunch of commas, and this is fairly straightforward. And all I'm going to do is reverse the coordinates. 6, -3. 1, 3. And 8, 4. It's a big problem. Notice I have the equation 7x minus 9. They want me to find the inverse of y equals 7x minus 9. So I'm just going to make that a little larger. So I'm going to add 9 to both sides. That's going to give me y. Oh, first step, I have to flip-flop the x and y. So that's going to give me x equals 7y minus 9. I'm going to add 9 to both sides. So that's going to give me x plus 9 equals 7y. And then I'm going to divide both sides by 7. Now this one I don't have to really write in y equals mx plus b format. I'm just going to type in that spot a fraction bar and then x plus 9 over 7. And that's my answer, part A. Now, to choose the correct graph, the original graph goes through -9, and then goes up 7. Goes through -9, and then goes up 7 over 1. Goes through -9, up 7 over 1. Notice the inverse graph slope is positive also. The slope is 1/7. The slope of the original graph is 7. The slope of the inverse graph is going to be 1/7. So it can't have a negative slope. It is not C. Positive slope, up 1 over 7. It's probably going to be B. It can't have a negative slope. It also has to be pretty about the line y equals x. So if you draw this diagonal y equals x, it's going to be symmetric about that line y equals x. That's another indicator of it being the inverse function. See how I drew y equals x? And notice, our graph is really attractive across that 45-degree angled line. Look how pretty that is across the line y equals x. That's an indicator that they are inverses of one another. It has to be attractive. The slope, the domain of any line is all reals, -infinity to +infinity. The range of any line is all reals, -infinity to +infinity. The inverse is also a line. That is going to be -infinity to +infinity. The inverse's range is also a line, -infinity to +infinity. So you're going to enter that 1, 2, 3, 4 times. Now I have to make this pretty across the line y equals x. So it would be symmetrical. It would be going sort of like a diagonal parabola to get the inverse to look pretty. So notice, this one looks pretty across the x-axis. That's not what I like. This one looks pretty across the y-axis. That's not what I like. This one doesn't even have the extra arm. This one, notice, it's curved over here and down here. It's choice B. These are really difficult to see if it's pretty or not. So let's make a bigger version of this. Let's see which one's prettiest. This one is not pretty across the diagonal y equals x. It cannot be A. This one may. I don't think it is. Oh, look at B. Look at B. Look at B. It looks like spider legs. Perfectly natured, symmetrical across the line y equals x. It has to be choice B. Must be. Solve. To do these, we're going to use the calculator. And we're going to hit this button right underneath the 1 button. It's the log base button. And notice when I hit that log base button, blammo, it gives me that. So I'm going to rewrite this. There's my base. I'm going to use this template of log base box of something. And when I hit that button, I'll be able to use it to solve these types of problems really rapidly. So the log base is going to be 1 divided by 7. So in there I put 1 divided by 7. And then I'll right arrow and put 49 in there. So when I type this in, log 1 divided by 7, then I'm going to right arrow and put 49. Should give me like -2, I believe. Bingo. That answer was -2. 5 to the x, and they just want me to plug in 5. That's all they're asking me to do. So that's going to be 5 to the 5th. To plug in 5 to the 5th, I'm going to hit 5, and then the Xbox button. That's right there, the exponent, and raise that to the 5th power. Big number, 3125. Just wanted me to plug that 5 into the X, and my answer is 3125. They want me to plug a 3 in. They want me to plug a 3 in. Now let's be very specific. We're going to type it in just like it looks. So I'm going to start off with the parentheses, then the fraction bar, then the 1 over 5, right arrow, close parentheses, and I'm going to raise that to the 3rd power. And it's going to give me the perfect answer, 1 over 125. Calculator can't. You can't ask for more than enough of those. These are a little tricky. A fraction to a positive power is going to decay. It's going to be choice C. In order for it to be choice D, it would have to be a positive number to a positive exponent for it to be D. Number 13, it's a fraction to a negative exponent. Basically what that is 5 to the positive x power. Because it's a fraction, which is supposed to be decay, but it's to a negative exponent, that's going to make it grow. So it's going to be choice A. Choice B could also be 2, but to the negative x power, or 5 to the negative x power, or 1/5 to the x power. To get it to decay, there's a couple of different things you can do. You want me to graph 2 to the x minus 2 plus 4? First thing I would try to do is graph 2 to the x. 2 to the x goes through 0, 1, and then it's going to creep along here and grow. I don't need to be exact. Now, I'm going to take that graph and I'm going to shift it opposite, same. So I'm going to shift it right 2, up 4. So this coordinate is going to go right 2, up 1, 2, 3, 4. That's my go through. Now, the horizontal asymptote was the x-axis. That's going to go right 2, up 4. 1, 2, 3, 4. And that's going to be my new horizontal asymptote. So my graph is going to creep along that new horizontal asymptote, go through that coordinate, and then go skyrocket up. And I'm going to get rid of the parent function. So now I'm going to answer the questions of domain and range. The domain goes to the left forever, and it goes to the right forever. So that's going to be negative infinity to positive infinity. The range, however, starts at this number, the horizontal asymptote, and it will never equal 4. It will never go below 4. So that's going to be parentheses. Y, minimum Y value of 4, which it never really hits. And then the arrow points upward also to the right, so the upward is going to give me a positive infinity with a parenthesis on it. These are like-based problems. There's 2 ways to solve this. I'm going to rewrite this as 4 to the 3rd. I'm going to rewrite this as 4 to the 2nd. 4 to the 3rd is 64. 4 squared is 16. And then I'm going to drop in the 3x and the x plus 2. I can now ignore those bases and solve 9x equals 2x plus 4. I distributed. That's going to give me 7x equals 4, or x equals 4 sevenths. To solve this, it looks very daunting. I'm just going to kick that x over to the other side. It's going to lift that 3 up. That's going to give me 27 over 343 equals x to the 3rd. Now to solve this, all I need to do is the opposite of cubing, which is cube rooting. And I'm going to cube root this whole big fraction. So I'm going to hit the cube root button, which is basically shift x box. And I have to put a 3 in for that spot there. That's the cube root. I'm going to arrow in, hit my fraction button, and put my 27 on top and my 343 on the bottom. Hit equals, and that's going to give me 3 sevenths. As a single logarithm. So I'm going to use properties of logarithms to rewrite this as a single logarithm. I'm going to make it a little bit bigger. I'm going to work on it over here. I have a log base 2 and a log base 2. So my single logarithm is going to be log base 2. Look for a minus sign. If there's a minus sign, you must put a division bar. Notice there's an x with a plus out in front, so the x goes on top of the division bar. There's a y with a minus out in front. The y must go on the bottom of the division bar. And the 4 that's out in front goes to the power now. So this is going to be x to the 4th. The 9 that's out in front goes to the power now. So that's going to be y to the 9th. So your answer for that problem is going to be log base 2 of x to the 4th over y to the 9th. Rewriting this, the log leg, that log has like a little leg, and that leg kicks that over to the other side. So that g kicks that 4 over, and it lifts up that 4, and it's going to be 4 to the 4th equals what's left over, so I get rid of that. So 256 equals 4 to the 4th. So you're going to type in 4 to the 4th, and yes, if you do it in the calculator, it should equal 256. Solve this, I'm just going to type this into the calculator. It will work. It will work if you type it in accurately. I don't need a calculator because I can see it's a 12 and a 12. The answer should be 1/5, but we're going to type it in the calculator just like it looks to verify the answer. So I'm going to hit the log base button. That's right underneath the on button, and there it is. And I'm going to type in a log base 12, like it says for the problem. Then I'm going to right arrow. Now I'm going to hit the shift x box to get the 5th root. I have to type in the 5th root, so I'm going to type in a 5 for the x box, and then I'm going to arrow in and put a 12, and it'll evaluate this rapidly. And there it is, 1/5. Number 20, I'm expected to graph y equals log base 4 of x minus 1. Well, log base 4 of x would go through 1, 0, then it would also go through 4, 1. It would creep up along the y-axis and then go through those 2 coordinates. off into the sunset. I want to graph the phase shift of that. And because it is nested inside of a parentheses next to the x, it's actually going to go right one. So each of these coordinates is going to go right one coordinate. This vertical asymptote is also going to go right one coordinate. So the vertical asymptote was originally the y-axis. I have to move that over 1 unit. So my new graph, if I erase this one, will come up along the line x equals 1, and then go through 2, 0, and through 5, 1. This graph got shifted right 1 unit horizontally. I'm expected to expand this. I'm going to simplify it. Select it, and I'm going to simplify this thing out. This is pretty complicated because it's got a nested radical about the whole item. See the nested radical? Well, a radical in logarithms represents square root. It represents 1/2. So that's going to give me 1/2 of the whole answer. Now there are 1, 2, 3 items. So I'm going to write log, 3 times. Base 2. If you're typing this in, you have to type in that base 2 as well. 3R7. 3R7. Now notice the 3 has nothing to it, so it's going to stay. The R has the 7th power. That's going to go out in front. So it's going to be 7 log base 2 of R. The Z, I'm sorry, there should be a Z there. That's a Z on the bottom. The Z has a 5th exponent to it, a 5th power. That 5th power goes out in front. Now, if it's on top, it has a plus sign, but I don't need a plus sign there. So I'm going to eliminate it. The 3 is on top. The R to the 7th is on top, so there's going to be a plus sign between those 2 items. The Z is on the bottom, so 5 log base 2 of Z is going to have a negative. I have to close my parentheses. When we did the homework, we got this right. When we did the quiz, we got it wrong, because in the quiz version, they distributed the 1/2 across. They wanted us to write 1/2 log base 2 of 3 plus, and this is strange, 7 over 2 log base 2 of R minus 5 over 2. Notice that 1/2 got distributed to each term of the expansion of the logarithm. Log base 2 of Z. And that, in the quiz, is what they only accepted. So if you're doing a multiple choice test, it'll either be this first one or the second one. This one we can type in the calculator. There is a basic log button, not a log base button. You don't need the base for this one. And that is just a little bit diagonal to the log button. So there's the log base button, and there's a just plain log button there. So I'm going to hit that log button, and I'm going to type in 0.01. Now, if you do this a couple of times, you'll notice that all you have to do is count how many spaces the decimal goes to the right to make it 1. So this answer is actually going to be -2. I can do these in my head if it's just a bunch of decimals. -2. So you would type in log of 0.001, and it equals -2. The pH problem is sometimes kind of scary. Sometimes they ask you what the pH is. I feel that's a little bit easier than the other version. If they ask you what the pH is, they don't. Oh, they give me the formula right here. They give me the formula. So you're going to type in your calculator negative log without the base, and it's going to present you with the parentheses, and you're going to type in the 4.9 times 10 to the -6, just like it looks. Type it just like it looks. So negative, not minus, negative log. Now again, we're using the just basic log, and then 4.9 times. I'm going to hit the times button. 10 x box to the -6th. Sometimes we don't have to close the parentheses, and I don't think we do on this one, but I'm going to. I'm going to right arrow and close those parentheses, and that's my answer, 5.3. They went it to the nearest 10th, so you just write down 5.3. This one, you can use the calculator. You can use the calculator. You can. You are allowed to use the calculator. However, ln and e cancel each other out. So the ln and e are going to cancel each other out, and your answer is just going to be 2 over 7. For 25, you got to use the calculator. There's no way around it. You have to type it in just like it looks, log base 2 of 9. So you're going to hit the log base button. Again, it's right underneath the 1 button. Log base 2, right arrow in, of 9. Now you have to be a rock star at rounding. They tell us to round it to the nearest 4 places. So you look at the 5th place. So 1, 2, 3, 4. I look at that. If that's 5 or above, I give the 9 a shove. If it's 4 or below, I let the 9 go. So my answer is going to be 3.1699. 600 grams of radioactive substance. 3 years later, oh, it cut in half. So originally, there was 600. 3 years later, there is 300. How much will be left over another 3 years later? Basically, you just chop it in half. It's 150. Not that bad. If they said how much will be left 9 years later, you would take half of that. It would be 75. And you would just be taking half. This 1/2 of 75 would be a decimal.